Good day everyone. My name is Charles Loshearitan from AF 2-4NS. Today I'm going to talk about aerodynamics. So this presentation provides an overview of the aerodynamics taught by Captain Nathaniel de los Reyes. So we have here first four forces of flight. The lift is the force that opposes gravity and keeps the aircraft in the air. Thrust is the forward force generated by engines or propulsion systems. Weight is the force due to gravity acting on the aircraft's mass. And drag is the resistance opposing the aircraft's forward motion. So in the thrust, we have forward force produced by the power plant or propeller or rotor. For the glider, it sacrifices the altitude for airspeed. So the conversion of this is potential energy, which is the altitude. Uh, it's sacrificing potential energy to kinetic energy. So the thrust uses second law of motion or the law of acceleration. Now for the drag, it is the rearward or retarding force caused by the disruption of airflow by the wing, rotor, fuselage, and other protruding objects. It is the net of aerodynamic force and a byproduct of lift and thrust. For the weight, it is combined load of the aircraft itself, the crew, the fuel, and the cargo or baggage. It is the vector you cannot change. For the lift, it is produced by the dynamic effect of the air acting on the airfoil and acts perpendicular to the flight path through the center of lift and to the lateral axis. So we have here the phases of flight. Takeoff, it is the air that the aircraft accelerates and becomes airborne. Climb, the aircraft gains altitude after takeoff. Cruise, the level flight at a constant altitude. Descent, the aircraft descends for landing. And lastly, landing. The aircraft touches down and decelerates. So we have here Bernoulli's principle. It states that as the speed of a fluid such as air increases, its pressure decreases and vice versa. It plays a fundamental role in explaining how lift is generated on the wings of aircraft. So the faster moving air over the wing creates lower pressure, resulting in an upward force called lift. Aircraft flies due to the differential pressure of upper and lower camber in the airfoil. So next is the Newton's laws of motion. So we have here the first law or the law of inertia. An object at rest stays at rest, and an object in motion stays in motion unless acted by an external force. Second law, or also called as law of acceleration, is the force equal to the mass of an object multiplied by its acceleration. So force is equal to mass times acceleration. And third law, which is the action reaction. For every action, there is an equal and opposite reaction. So for the first law, every object persists in its state of rest or uniform motion in a straight line unless compelled to change that state by forces impressed on it. For the second law, Force is equal to the change in momentum per change in time. So next, we have our lift as an equation. So lift is equal to 0.5 times center of lift times P or delta pressure times air density times velocity squared. Velocity squared. So the magnitude of the force of lift is directly proportional to the coefficient of lift, the density of the air, the area of the wings, and velocity, which is the airspeed. So correction for the CL, it is the coefficient of lift. So this equation can be rephrased into coefficient of lift times density of air times velocity squared times the area of the wings divided by 2. So that's how you calculate lift using the lift equation. So we go on to the coefficient of lift. It represents the lift characteristics of an airfoil. It varies with the angle of attack and determines the lift generated. A number that the aerodynamic cysts use to model all of the complex dependencies of shape, inclination, and some flow conditions on lift. So next, air density. It varies with altitude and temperature, affecting lift and drag. Air density is the mass of air per unit volume. So if this decreases and the total lift must equal the total weight to remain in flight. It follows that another factor needs to increase. So wing area. Wing area is the total planform area of an aircraft's wings. It's critical in calculating lift and drag forces. The lift varies directly with the wing area provided there is no change in the wing's planform. Velocity. It plays a significant role in lift and drag calculations. It is the aircraft's speed through the air. So the shape of the wing or rotor cannot be effective unless it continually keeps attacking new air. If an aircraft is to keep flying, the lift producing airfoil must keep moving. So controlling lift. Pilots control lift by adjusting the angle of attack and throttle. Increasing angle of attack generates more lift while decreasing it reduces lift. So pilots can control lift principally with the factors angle of attack and velocity or airspeed. So angle of attack, it affects lift and stall behavior. Angle of attack is the angle between the in or oncoming air and the chord line of an airfoil. So fundamental to understanding many aspects of airplane performance, stability, and control. The acute angle, it is the acute angle measured between the relative wind or flight path and the chord of the airfoil. So airspeed. Airspeed is the speed of an aircraft relative to the air mass it's flying through. It is the crucial it is crucial for flight performance. So lift to drag ratio. It indicates how effectively thrust is converted into lift while minimizing drag. The lift to drag ratio measures an aircraft's aerodynamic efficiency. The higher the ratio, the more efficient. It is the amount of lift generated by a wing or airfoil compared to its ratio. So airfoil design. So airfoil design involves shaping the cross-section of a wing. It aims to achieve desired lift and drag characteristics. So we have here Kruger for leading edge flaps and Fowler for trailing edge flaps. So airfoil construction. Choice depends on the application. Airfoils are constructed from materials like aluminum composites or carbon fiber. So wing construction. Wings are constructed with materials and structural elements. They provide strength, flexibility, and aerodynamic efficiency. So center of pressure can change with variations in angle of attack and is essential for stability analysis. Center of pressure is the point on an airfoil where the lift force acts. Airfoil behavior includes lift and drag variations with angle of attack, stall characteristics, and performance under different conditions. So, repeated. Sorry for that. So, next is inclination effect of lift. It refers to the fact that the angle of attack directly affects the amount of lift generated. Increasing the angle of attack generally increases lift until the wing reaches its critical angle of attack, leading to a stall. So weight. In aviation, it is a critical factor that must be balanced by lift for an aircraft to maintain level flight or ascent. It is the force of gravity acting on an object. It is the vertical force of gravity acting through the center of gravity. Center of gravity is the precise point at which the aircraft's mass or weight is said to be centered. It is critical in an airplane because its position has a significant impact on longitudinal stability. So location of center of gravity. The center of gravity is the point at which the aircraft's weight is effectively concentrated. Forward center of gravity enhances stability, while a rearward or aft center of gravity can make an aircraft less stable. An aircraft must be balanced so that it maintains stability in flight. So when you have forward center of gravity, you have a stable feeling, but nose heavy. Longer takeoff distance, increased induced drag, and high stall speeds. While you have when you have rearward or aft center of gravity may feel decreased induced drag, higher true speed due to the lower angle of attack, longitudinal stability decreases, performance impacts are due to lift to drag changes, impossible or difficult recovery from stall and spin, requires additional nose down force, heavy to compensate tail, and unstable feeling. So aircraft weight, overweight. Operating an overweight aircraft can compromise safety and performance. An aircraft is considered overweight when it exceeds its maximum allowable weight limit. So aircraft weight is concentrated on center of gravity. So when you have an overweight aircraft, you have longer takeoff run, higher takeoff speed, reduced angle and rate of climb, reduced cruising speed, shorter range, higher stalling speed, and longer run landing roll. So weight versus lift. In level flight, weight must be balanced by an equal amount of lift for the aircraft to remain at a constant altitude. Lift must be greater than weight for an aircraft to climb and less than weight for it to descend. So they have a direct. connection. Lift is necessary to offset the weight of the aircraft. So when lift is less than the weight, vertical speed decreases. But when lift is greater than weight, vertical speed increases. So thrust. It opposes drag and is essential for maintaining or changing the aircraft's speed and direction. Thrust is the force produced by aircraft engines that propels it forward. So it counteracts drag, drives the airplane ahead. It is generated by power plant, such as propeller or rotor or turbine. So for glider again, so potential energy, which is the altitude, converts is sacrificed that converts to kinetic energy, which is the airspeed. So it uses law of acceleration, which is the second Newton's law of motion. So force is equal to mass times acceleration. So measuring thrust. Engine performance is often rated by the amount of thrust it can produce. Thrust is typically measured in pounds or newtons. So propeller or rotor driven aircraft uses horsepower and turbine powered uses pounds. So thrust during acceleration. During acceleration, an aircraft's engines provide more thrust than drag to increase speed or climb. Increased engine power equals to thrust which exceeds drag. When you accelerate, means that the thrust is greater than the drag. So when thrust is equal to drag, it means you have constant airspeed. So thrust during deceleration. During deceleration, thrust is reduced or reversed. In the case of thrust reversal systems, slow down or descend. So in here, when you uh when you have lower engine power, means you have reduced thrust. So when you decelerate, it means that thrust is less than drag. To a certain extent, drag force will be lessened as aircraft slows down. So when drag is equal to thrust, aircraft continues decelerating until stabilized airspeed. So straight and level flight. So straight and level flight is a condition where the aircraft maintains a constant altitude and direction without climbing or descending. So it synchronizes angle of attack and thrust in all speed ranges. So lift changes with angle of attack and velocity for a given airfoil. Large angle of attack at lower airspeed or equates to low angle of attack at higher speed lift. So next, low speed flight. It occurs during takeoff, landing, and slow flight conditions. It requires higher angle of attack to generate sufficient lift, and aircraft are more susceptible to stalls in low speed flight. So, for you to have a maintained level flight, you should have raise in angle of attack while um, equating to the weight of the aircraft. So, cruising flight. It is when an aircraft maintains a constant speed and altitude during the main portion of a flight. It's typically the most fuel efficient phase. Aircraft is supported by a vertical component of thrust while it is in a nose-high position. Aircraft will climb if the angle of attack is not reduced. Reduction in angle of attack needs to be coordinated with the increase in power and airspeed. Otherwise, aircraft will descend if angle of attack decrease too fast and will climb if angle of attack lowers too slow. High-speed flight refers to flying at velocities close to or exceeding the aircraft's maximum design speed. Aerodynamic challenges such as drag and structural limitations become significant factors. So angle of attack must change as air speed varies through the thrust to maintain level flight. At a very high speed and level flight, it is even possible to have a slightly negative angle of attack. So drag, it is the force opposing an aircraft's forward motion. It includes various components such as parasite drag and induced drag. So we have here two types of drag. Parasite drag, resulting from the aircraft's shape and surface features, and induced generated drag generated as a consequence of lift production. So we have here types of parasite drugs. It can be categorized into form drag, which is the resistance due to the aircraft's shape, skin friction drag caused by air friction against the aircraft's surfaces, and lastly, interference drag resulting from the interaction of airflow between different aircraft components. So, parasite drag is comprised of all the forces that work to slow an aircraft movement. So, induced drag is anything that produces lift can create induced drag, such as the wingtip vortices taught by Captain de los Reyes to us. So it is created due to decreased wind airspeed, wherein angle of attack increases, induced drag increases proportionally. The amount of induced drag varies inversely with the square of airspeed. So let's proceed to parasite drag. So it is the displacement of the air by the aircraft, turbulence generated in the airstream, or a hindrance of air moving over the surface of the aircraft and airfoil. Airspeed increases, parasite drag also increases. So we have here form drag. It is generated by the aircraft and components such as the antennas, wheels, etc. due to its shape and airflow around it. For the interference drag, it is generated by the collision of air streams creating eddy currents, turbulence, or restrictions to smooth flow. Most drags is created when two surfaces meet at perpendicular angles. So skin friction drag is the aerodynamic resistance due to the contact of moving air with the surface of an aircraft. So to reduce the effect of drag, aircraft designers utilize flush mount rivets and remove any irregularities that may protrude above the wing surface. So four critical definitions. Rotor blade. It is the spinning wings which allow for lift on helicopters or rotorcraft. Stabilizer is a control surface other than the wings which provide stabilizing qualities. Chord. It is chord line longitudinal length as viewed from the side. Chord line, straight line intersecting the leading and trailing edges of the airfoil. Angle of incidence. It is formed by the airfoil chord and the longitudinal axis of the aircraft, which is designed into the aircraft and cannot be changed by the pilot. Attitude. It is the relationship of the aircraft nose with the horizon. Flight path. It is a course or track along which the aircraft is flying or is intended to be flown. Lift is a component of the total aerodynamic force on an airfoil and acts perpendicular to the relative wind. Center of gravity or CG, the average weight across an aircraft through which gravity is considered to act. Weight, it opposes lift via gravity, thrust, forward force which propels through the airplane, drag, retarding force which limits speed, and that's all you can find in the critical definitions. So for the conclusion, principles principles of flight. It is the characteristics that act upon the aircraft, such as the thrust, lift, weight, and drag. Lift is affected by the wind design, angle of attack, velocity, weight or loading, and loading, air temperature, and humidity. Bernoulli's principle in Newton's laws is in operation whenever the airfoil is generating lift. Four forces of flight are interacting to achieve flight. So we must overcome drag and resist gravity. So for constant airspeed, to maintain that thing, we have to have an equal thrust and drag. So lift equals weight, which means we are maintaining constant altitude. Aircraft angle of attack and velocity allows a pilot to maintain or manipulate lift. Air density are slightly under pilot's control as pilot can change altitude, while balance aircraft is equal to a hockey. Fuel burn, efficiency, etc. are all good. And lastly, accelerated level flight are in equilibrium when lift is equals tail downward force, or they are both equal, and drag and thrust are also equal. So understanding these concepts are vital for pilots, engineers, or anyone interested in aviation. The balance between forces such as lift, weight, thrust, and drag determines an aircraft's flight performance and stability. Bernoulli's principle, the center of gravity, and the various types of drag all play crucial roles in complex world of aviation. So that is all for my discussion, and thank you for your time and attention. Have a pleasant day, everyone.